Here's a quick look at dynamics effects. Dynamics has to do with the loudness of a sound. Well, we've got faders, right, to control the loudness of a sound. Well, sometimes the loudness changes that we need can be codified into rules. And so dynamics processes more specifically have to do with putting rules into place that treat sounds the way we want based on their loudness. And so here I've got a pretty noisy sound with a good bang here in the middle. But there's a lot of other stuff going on here. So we can set a threshold and say, hey, anything that's quieter than this, we don't want to hear it. We only want to hear the loud part. Let's just get that top bang there. But opening and closing this gate suddenly is introducing other artifacts, right? It's sudden silencing and unsilencing. So we're going to be introducing clicks into our sound. So what we want is a gradual attack and release. And so these actually sculpt the amplitude envelope that makes it through our gate. So we can have a pretty fast attack. Let's have a more gentle release. Okay, and maybe I can make my threshold a little bit higher so it doesn't get triggered on the bounce there. Okay. And if I want it to make it shorter, I can shorten the release. If I want to make it longer, there we go. We can make a more gentle attack. And I could lower the threshold maybe to see if I can get this extra bang in here, but use my attack and release to clean them up. So we can see where we're setting our threshold. That's our rule. The attack is the amount of time for the process to come into an effect, which is to let the sound through. And then the release time is the amount of time to let it go back to silence. And we've got a little graph down here of showing us how quickly the gate is opening and closing to let sound through. If you have a sound that's like this, that has a lot of small bumps in it, but is relatively consistent, we can start with a short attack and release, raise our threshold until we can just get some clicks through, and this isn't our final product. Although we could put it into a resonant filter and let this be the attack for a nice ringing filter. But we can think just in terms of our density of attacks that we have. I'll get this playing again. Now I can shape the release and give it a slightly smoother attack. And it doesn't have to sound like the original. Now it sounds more like maybe pouring water or dragging something through gravel. So we can get some interesting effects there, carving rhythms out of our material. They're just happening there in nature. And then we're going to look at the rest of the dynamics family of processes. The way Resolve has the mixer view set up, it's put some things in line here that it feels will be commonly useful. And so down at the bottom is a fader. Up above that is our pan controls. We've seen our EQ. And look, we've got the rest of our dynamics effects right here. And we've got this boring graph. You remember graphing y equals x in, 7th grade or something like that, and like y is just diagonal. Well, that means the output is the same as the input. Y is the same as x. Y, oh, y. Well, here we've got a response graph that looks the same way. Along the bottom is the input loudness in decibels, up to 0 decibels full scale. Along the vertical axis is the response of a gate. Whatever loudness comes in, we're going to set a different loudness for what comes out. This blue line here is our threshold, and so everything above the threshold gets left alone, that y equals x graph here. And then the reason why we want to have another gate is because this gate isn't totally shutting things off. It's just attenuating things by a value in decibels. This ratio control doesn't work on a gate. We'll get to that in a bit. But here we still have our attack time, which we generally want pretty quickly. We've still got a release time. And there's also a hold. Remember that time when we had a bounce in our sound before? Well, we could say anytime the gate opens and lets sound through, if you're going to open at all, stay open for at least this long. That's our hold time here. And so you might think of that as a granted minimum value for the sustain portion of an attack envelope, an amplitude envelope. So this is the response curve of our gate. And so, yeah, once it gets below a certain threshold, its output is silenced by a whole lot. Very useful is this gain reduction indicator right here. See how it shoots up to 0 and then shoots down. Okay, well, what if we use some of these other controls? So we'll turn off our gate for a second, and we can turn on a limiter. Look, we get a new threshold that's going a different way. And what we're doing is setting a maximum loudness for our sound to be. And so whenever our sound comes in below that threshold, there's our y equals x line. Anytime it comes above that threshold, it's going to get pinned, or so the idea is, pinned to that threshold. And so let's see, we'll keep it. Yeah, it'll be quieter. Now we can see the gain reduction. This is turning down the volume however much is needed in order to keep it as close as possible to this threshold. Now it also has attack, hold, and release, and it has a delay time because it needs a little bit of time to calculate the amplitude at the moment. And we can't use instantaneous amplitude, or that would create clipping and change the shape of our waveform. But what we're doing is, well, we're flattening the curve. Remember that from many pandemics recently? So we're taking this attack transient, the thing that passes quickly and is loud, and we're turning it down. And so we also might want makeup gain in order to bring our sound back up to where we were originally. And so this has the effect of originally reducing the loudness of the attack, but then with the makeup gain, we can put the attack back where it was, and then we're making the rest of the sounds louder. We're making the quieter parts of this sound louder. This is how guitar sustain pedals work, for example. So we've increased the sustain of our sound. If we don't want to be so hard about this limit, instead of a limiter, we could use something that does something similar here. We've still got this threshold, and there's what a limiter might look like, except we've got this ratio control. And what we're doing is we're saying, okay, well, you wanted to be on this y equals x skyrocket curve here. Let's split the difference. And so a 2-to-1 ratio would split between a horizontal line and our y equals x curve right there. So it's turning it down, but only by half as much as it normally would. And so this is a gentler alternative to a limiter, and it's called a compressor because it's compressing our dynamic range. And so with each of these, particular threshold values aren't so useful to prescribe across multiple applications. You really want to look at how much gain reduction is happening here. Think about the attack of your sound, how much of it is getting made dull, muddy. Compressor can act as a filter because it's counteracting fast changes in loudness. So once again, all these effects are interrelated here. And so here our attack time is, in one sense, exactly like what it was with a gate. It's how much time it takes to become active, how much time for the release, how much time it takes to let it go back. But in another sense, it's backwards because our compressor is activated when the sound gets loud. And so the attack tells us the time that it takes for the compressor to turn the sound down. And so it's useful to think about it in terms of an attenuation monster. If you get too loud, the attenuation monster is going to attack you, and it will hold you until you get below that threshold, and then it will finally release you. And so here the attack is how long it takes the compressor to go into full effect, turning the sound down. Or you might think about it as how much of the original attack you want to let peek through. Fast attack time is really catching that attack transient. Here, if we can make a slower attack time gets that tap in there. Okay, and then we can set our threshold and our ratio to have a softer version of a limiter, and we can think about not just one level of loudness, but all the loudnesses around it. How much do we want them to all be like each other? That's our ratio. What range of loudnesses do we want to affect? That's our threshold. And back to our gate. Well, let's see. We'll turn our compressor off so we can see one thing at a time. Our gate, if we max out the range there, we were setting a threshold below which things would be silenced. Well, we don't have to be such a hardline process with that either. We can use what we call an expander that allows us to use this ratio control. And here's with a very steep ratio, far from 1-to-1, then we'll get something closer to like a gate. With a ratio that is closer to 1-to-1, we'll get closer to that y equals x curve here. And so this is splitting the difference in the other way. And so if our sound was below our loudness threshold and we ordinarily would silence it, a 1-to-2 ratio will reduce it by half as much instead of completely silencing it. We also have attack and release times to tweak here too. Expanders are especially useful if it would be weird if we totally silenced the sound. But if you're in total control of the composition rather than trying to faithfully present a realistic recording, if you're totally in control of it, a simple gate like we were playing with before will give you much more control and won't have any problems here. The expander is useful for when you want to let a little bit of that sound through. And those four, one hardline and one compromising version of each, are our Dynamics family of processes.